to finish up here, I'm going to show you a proof of some of the shortcut rules. So I'm not going to do all of them here. In fact, I think I'll do 3. I think I'll show you that the sum difference rule, and I'll do it for the sum. I'll show that the derivative of the sum of two functions is the sum of the derivatives. Then I'll do the product rule, and then I think I'll show that the derivative of sine of x is equal to cosine of x. And that'll just give you a little sampling so that you can see kind of how where these rules are coming from. So they all come from the limit of the difference quotient. So if you remember, f prime of x is defined to be the limit as h goes to 0 of f of x plus h minus f of x all over h. So if I want to show the derivative here of, let's say, f of x plus g of x, if I want to show the derivative of this here, well, the rule says I would just take the derivative of each piece and add the two derivatives together. Okay? So let's show that this is actually the case. So, so I can, maybe just to help the notation here, let's let h of x equal f of x plus g of x. Okay, then I can say the derivative of h of x is equal to the limit h, I probably shouldn't have used h there, but because now I got h goes to 0, that's not the same as that h. So, yeah, let's say w. We'll call it w of x. There we go. And now I'm going to do w prime of x. As h goes to 0, this would be w of x plus h minus w of x, right? All over h. I mean, that's the difference quotient. But to plug in x plus h into w is just to plug in x plus h into each of these, right? So I'm going to get the limit as h goes to 0 of f of x plus h plus g of x plus h, and that's what I would get when I plug in x plus h into w. And then to plug in w of x is just going to be equal to this here, so it'll be like f of x plus g of x, and this would be like in parentheses here, and then all of this would be over h. So basically it's putting this here into the difference quotient form. Okay, well, then this is the limit as h goes to 0. I can distribute the negative sign, and then I can commute those around. And so I could write it like this: f of x plus h minus f of x plus g of x plus h minus g of x, and all of this is over h. Okay, so now what I can do is I can split this up over a common denominator of h, and if I do that, then I would get the limit as h goes to 0 of f of x plus h minus f of x all over h plus g of x plus h minus g of x all over h. And it would look like that. So then, using that limit rule, the limit of the sums is going to be the sum of the two limits. So the limit of this and the limit of that. Well, the limit of this as h goes to 0 is just f prime of x. And the limit of this is h goes to 0 is g prime of x, right? And that's what I wanted to show, that the derivative of the sum here is equal to the sum of the two derivatives. So that would be that rule. That's probably the simplest rule. So now let's show the product rule. Okay, so I'll just use y is equal to, we'll say f of x times g of x. Okay, and so, and I want to derive, so the rule says dy dx is equal to f prime of x times g of x plus f of x times g prime of x, right? So if this is y, so dy dx is going to be the limit of the difference quotient of this, so as h goes to 0. So I'm just going to plug in x plus h into here. So it would be f of x plus h times g of x plus h minus just f of x times g of x, and then all of that over h. So that would be putting this inside the difference quotient. Okay, so now what I'm going to do is I'm going to take the limit as h goes to 0. And so let's think about this here. What I would like to do is I would like to get like f of x plus h minus f of x, okay? And I mean just that little bit here, because then that's going to start a difference quotient for f of x that's going to give me this. Okay, well, one thing I can do here, so this is like this. So what I'm going to do is I'm going to subtract, and I want an f of x, but then if I could factor out that g of x plus g, that would be good, because then I would have f of x plus h minus f of x. Okay, but now if I subtract, if I use this term and I subtract that term in, then I got to add that term back out. Okay, and then f of x times g of x all over h. So let me show you what I did here. Okay, I didn't change this at all. What I did is I brought these in by, I subtracted it and then added it. So if you combine these here, it would go away and give you this. So I haven't changed the form at all. But notice what I can do here is I can pull that g of x plus h out, and then I would get, and here what I'll do is I'll just do this. I would get like f of x plus h minus f of x, all of this times g of x plus h. Okay, so that's pulling it out of there. Okay, but then I have plus, and now from here, what I'm going to do is I'll pull out an f of x. I'll distribute that out this way because I got one in both of those terms. And the really nice thing is now I'm left with a g of x plus h minus a g of x. Do you see? And that's going to form like this difference quotient for that one. And this is perfect because as h goes to 0, this will go to g of x. And that is going to be f of x. And then I'll have these two difference quotients. So all of this divided by h. Okay, so now I can split this up over the common denominator of h here. And it would look like this. I'd have the limit as h goes to 0 of f of x plus h minus f of x all over h times g of x plus h plus f of x times, and now this h is going over here, g of x plus h minus g of x all over h. So basically you combine these, you can multiply all this and bring it back together to there. So I'm just splitting it up like this. And now when I take the derivative of this, then now when I take the limit of this with respect to h, I can take the limit of this is a product of two functions, so the limit of the product is the product of the two limits, right? Well, the limit of this as h goes to 0 is f prime of x, And then the limit of this as h goes to 0 is just g of x plus, and then I have f of x. So the limit of a constant is the constant. Okay, it's not 0. That's the derivative of a constant. And then the limit of this is the other difference quotient for g of x, is g prime of x. And you can see that is the product rule. Okay, so that's actually how you could derive the product rule then from the difference quotient. That's how it works. Okay, so now what I want to do is I want to show this d of x of sine of x is equal to the cosine of x. Okay, now in order to do this you need some important limits. You need basically you need the limit here as x goes to 0 of sine of x over x, and that's equal to 1, and that's one that I proved. Okay, so there's another limit that's similar, and you can actually use some identities to do this. I'm not going to prove this one, but it would be it'd be like cosine x minus 1 over x. This is actually equal to, so as you go to 0, cosine x is going to 1. Okay, so you get 1 minus 1, which is 0, but this is going to 0. 0 over 0 is undefined, and so you just can't plug it in and know that this is 0, but they both go to 0 in such a way that this is actually, this limit here is actually equal to 0. Okay, so 0 over 0 is actually indeterminate. Okay, this is 0 over 0 and it goes to 1, but this actually goes to 0. And let me make sure I'm using that right, because I actually have the proof over here. Yeah, so that actually goes to 0 here. Okay, and again, this is a limit. I'm not going to prove this limit, but we're going to use those two limits. And you could prove this limit actually using, you actually prove this using this and some identities. But let's just keep it like that here. And so now what I want to do is I want to find the derivative here, d dx of sine of x. And so again, I'm going to use the difference quotient limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. That's the difference quotient. So now what I need here is I need the sum difference identity. So you could go back, check that out if you don't remember. But what it's going to be here is you're going to split this up by doing sine of x cosine of h, and then it'll be plus cosine x sine of h, and then you'll have that minus sine of x, and all of this will be over h. So you're using the sum difference identity to split it up like that. Now I'm going to rearrange these. I'm going to bring this sign over here. So I have the limit as h goes to 0 of sine x cosine h minus sine x, okay, plus cosine x sine h, all of this over h. Okay, so I have this limit. And now what I can do is I can factor a sine x here. So I'm going to rewrite this here like as follows. I'm going to factor out that sine of x, and then I'm going to be left with this limit over here. This would be like cosine h minus 1 over h. Okay, and then this would be plus cosine x, and this is like sine h over h. So you could combine all this and you would get this up here. Okay, well now we can take these two limits. So this would be the limit of the, this is a product, so the It would be the product of the two limits. Well, this would just be like sine x, but this here, this limit is 0, right? And then this would just be cosine x, because as h goes to 0, that's a constant. And this is equal to 1. That limit is equal to 1. And so this here is equal to just cosine x. So the derivative of sine is equal to the cosine of x. So once again, that's using the difference quotient to derive these rules. And so basically, that's what you're doing. These rules are they all come from this difference quotient, and so they all are derivatives. It's just you don't have to go through this every time. Once you have a rule, you can use that to find the derivative, and it's a lot easier that way.